Okay, we are doing number 11 on page 211. We are trying to decide how these two triangles are congruent. Okay, now we move over here. Don't trip, Burns. Okay, the first thing you always do when you're doing a proof is you always have to start with the given. And as you can see up there, V is equal to S as alternate interior angles, and TV is equal to QS. And we're trying to prove that VR is congruent to SR. So angle 1 is equal to angle 2 because of vertical angles. And then triangle TVR is equal to triangle SQR through angle, angle, side, because it gives us angle, angle, side. And then right there, properties, well, that's just, yeah, that thing. And then
its angles are congruent, so sides are congruent. That's what it is.
Yeah, what Burn said. Okay, now come up here. Oh wait, crap. Okay, now, well, okay, now we are going to do number 12 on page 211. Okay. And once again, we are trying to prove how the true triangles are congruent. Did you show me the picture? Okay, first you always start with the given. There's your given. And now we're trying to prove that triangle EJG is congruent to triangle FKH. And then EF plus FG equals EG. That just proves segment addition. That's when you add two segments. And then GH plus FG equals FH. That's also segment addition. And you can see that on the triangle over there. And then EG is equal to FH. See, as you can see here, substitution. Angle E is equal to angle F, as angle G is equal to angle H. Corresponding angles are equal. And then finally, triangle EJG is equal to triangle FKH through angle, side, angle. Okay, now if you all come over here, we are going to do number 17 on the SOL practice sheet that did not have a year. We are trying to prove the two triangles are congruent once again. Thank you, Burns. Okay, there's your picture right there. That's a P if you guys can't tell. Okay. Given that M is the midpoint of LN, and KP, given M is the midpoint of LN and KP. The given information is sufficient to prove that triangle KML is congruent to triangle PMN, by which the postulate / theorem, these are your options: angle, angle, side, side, angle, side. You can tell by looking at it that it will be side, angle, side because it has two congruent sides and they share a common angle. Well, they don't have to share that one. They can have alternate interiors in a few different places. So side, angle, side is the one that you want to go with. And now you want to do one? You want to start? Or do you want me to do one more? Okay, now we are going to do number 19 on page 204. Right here. Okay. Always start out with the given. Okay. Always start out with the given. And then this one's kind of special. HJ is equal to KJ. GJ is equal to LJ, as GH is congruent to LK. And this stands for congruent parts of congruent triangles are congruent. Okay, and then we go down here. HJ is equal to KJ, GJ is equal to LJ. Definition of congruent segments. You can tell that when you look at the picture. HJ plus LJ equals KJ plus JG. Addition property. It's when you add two sides. Sorry about that. And now KJ plus GJ equals KG, and then HJ plus LJ equals HL. It's segment addition, because you're adding two segments. And then usually after segment addition, you have a substitution, which is right here. KG is equal to HL, and then KG is equal to KG is equal to HL both times, and then by substitution. And then KG is equal to HL by definition of congruent segments. Once again, segment addition, congruent segments. GL is equal to congruent to GL. We all know that's the reflexive property because it repeats itself. And then triangle GHL is congruent to triangle LKG by side, 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 because you have all these segments that are congruent of both triangles, and then you can add them up and they can be equal, and then you can substitute them in and they'll be equal to each other. Okay, now we are going to the 2006 SOL review packet. It's on number 17. We're proving that triangle ABD is congruent to CDB. And then I guess they don't give you a given here because it's not a proof. Angle A is equal to angle C. Opposite angles are congruent, and I guess those would be alternate interior angles. AP is congruent to BC. Opposite sides are congruent. AB and then BC. Or AD, I'm sorry, AD and BC. And then AB is congruent to CD. Opposite sides are congruent. And then you can decide that triangle ABD is congruent to CDB by which postulate / theorem, side angle side. Side angle side. You have a side, and you have an angle, and you have another side.